again, we're still on the same objective. We're going to simplify exponential expressions using multiplication properties of exponents. And we're still on multiplication. So once again, I give you guys definition for the concept, which is exponential expressions. We said they're numerical and variable expressions raised to a power greater than 1. I gave you guys examples and non-examples. And we said the non-examples are not examples because, tell your neighbor why these two are non-examples and why this one's a non-example. Right. So I heard because these have an equal sign and they're equations, and right now we're looking at what? Expressions. And the other one, this is an expression. However, what is the other requirement? It has to have an exponent greater than 1. Okay? So from there, I gave you guys steps, and I said identify the exponential expression is a product of powers, power product. Use the appropriate property and simplify. Yesterday, we just covered the first property, which was this one, the product of powers. Okay? So, what was product of powers before we got into it? I said write this down. You need to remember that whenever you see a number, you write it with an exponent of 1. Whenever you see a variable, you need to write it with an exponent of 1. And we said that there is some properties that we need to know concerning negative numbers, but whenever you see a number, like I said, you need to write it with an exponent of 1. We talked about the commutative property of multiplication, which says that when you have numbers and there is multiplication throughout, if you change the order, it doesn't matter if you change it or not, the product is still the same. The associative property says if there's multiplication throughout and you group numbers differently, the product is still the same. We went through some examples, something similar to this, and then we said that whenever you have two numbers or two variables that have the same base, what do we do to the exponents? Add. We add them, right? Okay. We went through some examples. We went through this example, that example, and we left off, let me see, at that one. Okay, copy that, please. Example 2, A and B. They have the same base. What do? Add. So this is 7 to the 12. Okay. Look at this one. Let's use the commutative property. First of all, I'm going to switch these around. So this becomes 3 to the negative third times 3 to the fourth times 5 to the eighth times 5 to the second. Associative property, these two and these two. Let's see. Let's look at these two. Same base? Yeah. So therefore this is 3. What is negative 3 plus 4? 1. And then I have times. Same base right here? Yeah. So this is 5. 8 plus 2, that's 10. And if we rewrite that, this becomes 3 to the, you know what? I'm not going to write the multiplication sign. I'm going to write it in paren and to the 10. Next, copy these down. Go. Once again, you need to show the step for commutative and associative. So here we go. I'm going to switch these two right here. So this becomes m to the first times m to the fourth times n to the negative fourth. Cancel if you did that. Okay, good. Now we associate these two right here. Are they the same base? Yes. So then m, 1 plus 4, that's 5. And I'm going to bring down the n to the negative 4. And we're done. Okay, let's solve it. Simplify it. Sorry. Go. So use the appropriate property. So the appropriate property that we're on is the product of powers, right? Okay. So then what do I do? X to the power of 1 and x to the power of negative 1. So you associated these two, and what did you get? X to the 0. And I'm going to bring down the next one. What do you get there? X to the negative 3. I bring down the other one. And what do you get there? X to the power negative 7. And like I said, we're going to do one more step, but once we get this. For right now, I'm good with this. You got these already? Let me go into a word problem with these. All right. It says, light from the sun travels at about 1.86 times 10 to the 5th miles per second. It takes about 15,000 seconds for the light to reach Neptune. Find the approximate distance from the sun to Neptune. Write your answer in scientific notation. Okay? So first of all, with word problems, I like to start underlining stuff so like that I know what I'm looking at. Here I have miles per second, which is a rate. Is that correct? Also, we have over here seconds. What is that? Time. And what are they asking us to find? Distance. So let's see, distance, rate, and time. So my formula for that would be what? D equals R times T. Search. Remember that one? All right, so let's substitute and find our distance. So the rate is right here, which is 1.86 times 10 to the 5th. And we're going to multiply that times, what was the time? 15,000. 15,000. Okay. All right. And we need to find our distance. Okay. So now, I can multiply this one. Everybody look up to the screen. I can multiply this one and get a huge number, and then multiply this one and get another huge number, and then simplify to write it, because they want our answer in what? Scientific notation. Or I can start from the get-go and rewrite this one in scientific notation. So check this out. To write this one in scientific notation, I'm going to move the decimal over 4 times, and I'm going to get 1.5 times 10 to the what? To the 4. How many times did I move the decimal? 4. Okay? Okay. We went from 15,000. We're going to write it in scientific notation. So therefore, to write in scientific notation, I need at least one whole number and from there a decimal. Are we there? So if there's an invisible decimal here, I move it to the left. 1, 2, 3, 4. So therefore, 1.5 times 10 to the 4th. We're using base 10 for you guys didn't cover scientific notation? Scientific notation uses base 10. Base 10. Okay? So this, we rewrote it in scientific notation. I'm just going to bring this one down, which is 1.86 times 10 to the 5th. You're like, oh, wait a minute. This is starting to look familiar. I can use the product of powers property by using commutative property. You guys see that? Yes, you do. So then I'm going to move this one here and this one here. So therefore, this becomes 1.86 times, what goes here? 1.5 times 10 to the 5th times 10 to the 4th. Associative property, can I associate these two and these two? What is 10 to the 5th times 10 to the 4th? 10 to the 9th. And then I just need to find my computation. I'm going to do it over here on the side. 1.86 times 1.5. Let's see. 5 times 6, that's 30. I got 3. 5 times 8, that's 40. Plus 3, that's 43. I got 4. 5 times 1 is 5. Plus 4, that's 9. 1 times 186 is what? 186. 0 972. How many decimal places? 3. So therefore this is 2.79 times 10 to the 9. And that's the distance from the sun to Neptune. Everybody see that? Okay. Any questions with these word problems? Yes? How come? So with that said, on our notes, did everybody take note of this? Okay. So we're going to stop right there for that one, and let's go to the new property, which is power of powers property. Power of powers property. And we're going to write example SQ. Example SQ. Super Q, get it? Because of the powers. Power of powers, that's right. So once again, we already finished the product of powers property. Now it's the power of powers property. You write example SQ, open parentheses, 2 to the second power, close parentheses, and raise that to the third power. Pens down. Okay, here we go. So, what does that property say? I'm going to leave a little bit of space here, and I'm going to simplify it over here. Think about it. What did I just do to those numbers? Okay. Yeah, good thinking about it. Tell your neighbor, please. Okay, copy that, please. And if that's true for numbers, therefore, see if you can simplify this one. Leave a space in between like so, please, and write it over here. Okay, tell your neighbor what you got for the second one. Who got x to the 20th? Okay, so once again, by looking at the exponents, and we for the first one, 2 and 3, and we got 6, what did we do? We multiplied them, didn't we? How about this one? What is 4 times 5? 20. Okay, now here goes the y. I'm going to do that in blue. In blue, white, black. Hello. All right, here we go. Check this out. The 3, everybody look up to the screen. The 3 tells me that I'm going to multiply whatever is inside of the parentheses times itself how many times? 3. So this becomes 2 to the second times 2 to the second times 2 to the second. Is that correct? And we already know the product of powers property, right? If they have the same base, what happens to the exponent? Add. What is 2 plus 2 plus 2? 6. Look at this one. It tells us to repeat whatever's inside the parentheses how many times? 5. So this is x to the 4th times 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 x to the 4th. Once again, the product of powers property tells me that if they're the same base, we add the exponents. What is 4 plus 4 plus 4 plus 4 plus 4? 20. Fairly simple? Okay, do this one by yourself. Parentheses. 7 to the 5th, close parentheses, to the 13th. You don't have to show, just simplify it, please. So, who got 7